Okay, everyone, come on in, take your seats. Let's get started with the last plenary. Looking for confirmation that our virtual attendees can hear okay in the Zoom. Okay. If one of you, yep, we got a one thumbs up. Okay, that's good. Good enough. All right, welcome to the final plenary of the Rubin 2023 Project and Community Workshop. Today we do the breakout summaries. These slides are available at ls.sd/zt4. That is an edit link, so do be careful if you go and look at that slide deck. As a reminder, we have a code of conduct for this meeting. It's posted on the website and available at the QR code. If you have experienced any or witnessed any violations of the code of conduct of any kind, please do reach out to our workplace culture advocates. They're listed here with their email addresses, and those are the people that you should be talking to if that did happen. Keep checking the name tags for those stickers, wear the mask if you want to, keep an eye out for those social battery pins, and if you feel unsafe at any time, even for the rest of the day, do send an email to Rubin2023-helpline. For our virtual participants, please remain muted when you're not speaking. We don't do question time. This is all breakout summary reports, so there is no Q&A this time, but there is a Slack channel where you can ask questions of the speakers or make comments as we go. All right, instructions for speakers. We're going to take our instruction from the students who did wonderful flash talks, and when the day comes up, we'll go day by day. And so when you see the day come up for the day that your session was, you're going to do like Will is doing, and you're going to get together over at the left of the stage. And then when you see your slide come up, you will come up to the podium, use this microphone. You'll be able to see your slide in front of you. You'll speak to your slide for please no more than 60 seconds. I'm not going to really be timing you. Just to, try to keep it snappy. We'll keep it moving through. We've got about 70 slides, I think, to get through from all of the sessions this week. So just keep it going. If you are a virtual speaker, I don't know if anyone is going to be virtual, but if you were planning to present your slide virtual, when you see your slide appear, just unmute and speak to that slide right away. If there is no speaker for a given slide, we're going to just read it for 20 seconds and then we'll move on. At the end of every day, I'm going to pause, refresh the slide deck because I know some of you are working at the very last minute. So refresh the slides. That gives people time also to get up and take their place over at the side of the stage, and then we will keep going. So that's what's about to happen. So now we're on Monday. We start with Michael.
Hello, everybody. I'm Michael Strauss. I chair the Science Advisory Committee. Actually, I realize that that's misnamed. Let's see. One of the things that we did was welcome 6 new members of the Science Advisory Committee. You can read their names here. Many of them are in the room or maybe on Zoom, so welcome them. A theme of our discussions, many of the things that we found ourselves talking about were echoed in sessions later in the meeting. You can see them listed here. We're thinking about the future of the website for the scientific community, the LSST website, thinking about the in-kind contributions, Rubin and Euclid pixel level analyses, plans for early science and science verification, which we heard a lot about throughout the week, and so on. And that kept us busy for several hours on Monday morning.
Hello, everyone. I'm Sierra Villarreal, and I'm just giving the quick summary for the LGBTQ social that we had. So we introduced a new name, so we're going to have to change all our channels, but we decided the acronym Queer Astronomers at Rubin. I made a silly logo. But overall, we had some really... Yes, logos and bad acronyms. We love them. So we had some really nice unstructured discussion, let people get to know each other in the community ahead of the meeting, and it seems to have done a lot of good as far as I can tell. And we had a nice little lunch social after. It was great. So just as a reminder, we have 2 Slack channels. There's the members of anyone in the community can join in by asking an existing member, so just send me something on Slack potentially. And anyone can also join the Allies channel, which is open to the entire Rubin community. And just really thanks to the broader LGBTQ community for helping put this all together, because it's not just me, I just happen to be the person reading the slide.
Also on Monday, we had a photometric redshifts for LSST objects session. This year, our PhotoZ session focused on mostly science talks related to LSST PhotoZ. So we had Jeff Newman, Sam Schmidt, Simona May, Julia Gschwend, Renee, and Lozek, and Bipatrib all gave wonderful talks about various aspects of LSST photometric redshifts. But overall, the theme was working together to produce quality photometric redshifts to enable a wide variety of LSST-related science goals. Igor.
Hi everyone, I'm Igor Andreoni, and with Sarah Bonito, we chaired the TVS dedicated session on Monday. We heard 3 great talks by Somaya, Michaela, and Annibal about generation of maps for microlensing model of lens quasars, the Fermilat light curve repository, which can be pretty useful to TVS members, and how we can combine Rubin and Roman data for microlensing planetary events. The discussion took a fair bit of time, was really useful. There was a suggestion to create a group dedicated to interface with brokers that we will definitely consider. There will be leadership opportunity to revive subgroup and task forces, especially for more junior people. Some groups will still need some restructuring, and there was also the outrageous proposal to wipe out subgroups altogether. So all these suggestions will be thought upon, and we will keep you posted about decisions and the request for input. Thank you.
Okay, this year we had another year of welcoming our new to Rubin colleagues by just absolutely inundating them with information, terms, and acronyms, and like a very dense 90-minute session, but that also gives them like a nice slide deck to refer to in the future. So I want to thank all of the presenters from the various different Rubin systems who were there that day, and remind everyone that there's a searchable database for terms and acronyms that you can find in our website and use at any time. It's got it all in there. Yeah.
If you want to add anything to that acronym database, you can give it to me and I'll do it for you. So we had an all-hands meeting for data management. As we transition to operations, this is data management, both construction and operations. So we had a few people, and you see most of them in the little picture here, that we took afterwards. A few people who were in the room didn't make it in the picture because they didn't hang around or they didn't feel they were part of data management, but you're always welcome in our pictures. It was a little bit of highlights. We went through the networks with Julio and Hernan. This is the long saga of simplifying our networks. We talked a little bit about prompt processing because we now have this running at USDF. We think this is a nice highlight, and it's come up in a couple of places in the meeting. So Ian gave us a rundown of that, running prompt on Auxtel images. Then we had a call at the JTM for some summit data handling. So we had 3 little talks organized by Yusra, one from Fritz on the electronic stuff that he's doing with the environmental system, Claire on TMA data analysis, and Angelo on the EFD training that he did when he was down there for a few months. So these people have been down to Chile for a couple of weeks and helping out on the summit and trying to do stuff, and it's really great. And Claire was mainly working remotely. There was a few lightning talks because we want to just give people the opportunity to talk about what they're up to. Source injection with Lee, Aaron on cell-based coads, so great advancements that we have in the pipelines. And then Brian on scaling tests and deep coads, which is also very interesting for our future processing. And then we repaired in the evening down to the Sea of Glass, and Frosty organized a great evening with Kai for us there, and we enjoyed some drinks and a social evening with everyone in DM. And that's the picture up on the top right. That's it.
Hi, I'm Simona May. I'm one of the 2 co-chairs of the Galaxies collaboration. So we had the section on Monday for the collaboration, and we started by a general presentation on what we do, why we do it, and how to become a member. We then discussed some issues that are collaboration-wide, like publication policy and how to help in the commissioning effort, both establish metrics and giving FTEs. The third thing was early science, how to get prepared for early science with LSST. We could finally speak about science, and we spoke about challenges, about discoveries. So on the discovery side, we had the presentation on the discovery of new low sulfur brightness galaxy in a range of mass that is not much explored. We also discovered that there is a large amount of dust in some of the LBS, like it was not found so far. And we discovered filaments around the galaxy clusters. As challenges, there was a talk that pointed out that what we measure for the intracluster medium is not what has been simulated in simulations, so that could bring new methods to measure the intercluster medium. And then the other challenge was that uncertainties in photometric redshift can bring very different estimate of galaxy formation and evolution. Thank you.
All right, we're gonna look at this slide and read it for 15 seconds.
Oh, there we go, sorry.
Yeah.
Oh, you have it.
Yeah.
I forgot.
I got it. And I can do the refreshes. Okay. Yeah, it's all good. You're very welcome. Okay. Yeah, we're waiting our 15 seconds for, yeah. Yeah, somebody made the slide, so I'm going to appreciate it. Yeah, exactly. Yeah, thanks, Peter. Okay, we're moving on to Tuesday, so if you had a slide on Tuesday, let's get you up over here. I think this is another slide. Ryan couldn't be here today, and I think we don't have him on Zoom. So we're going to read this slide for 20 seconds. That's wonderful. As every year, it's always great to have the students here, and they did great. All right. I think this is Jeff Barr, or maybe Holger. Is someone speaking to this one? Okay, great.
Yes, this was a session that I ran along with Holger Dross and Matt Ramori and a few others. Actually, there's a lot of contributors to this computerized maintenance management system. This was a follow-up from a session we had last year, and this is one of those cases where the sequel was a little better than the original. We actually had a little more progress to show. We had a demo from the developer of this, the contracted company that we have, Technoteca, and that said, that we are making progress. I would have to say that the progress in a year is not as impressive as I had hoped it would be. First, the good parts. This tool has proven to be really good and adaptable and capable of all the things we need it to do. That's pretty obvious. Participation from all of the stakeholders. This is largely having to do with hardware, so it's mostly telescope and sight and camera team, but is ramping up fast, and that's helping a lot. And the pace of our progress in just the last months is really, in this implementation working group, is going very well. The things that have been hard, where I would have to say our first shots across the bow were not that successful, were in figuring out how to break down the observatory for maintenance. It's not the same thing as WBS, it's not the same thing as SysML, model trees just don't work. So we're having to reinvent that. Also, the documentation, we have tons of it, but it's not particularly easily referenced, and they're not camera ready for it to be incorporated into a maintenance system. So that's a challenge too. And we've even had problems in 3D modeling so that we can bring our models in, and those are available to technicians in the field. You can see some examples. The picture up in the top right corner shows you the participation in the room. And one of the interesting things was that we had Noir Lab, a representation group from Noir Lab there, and they have also chosen this tool, the same tool we have, OpenMate, as their CMMS as well. And so that really helps us a lot. I think we're going to have a lot of good synergy with them, and going forward, that will help smooth our transition into Noir Lab as a Rubin entity. Thanks.
Hello, I'm Gloria Fonseca Alvarez. I'm presenting this on behalf of Alicia. So we had a Allies Across Rubin support session. The goal of this session was to bring people from marginalized communities together with allies. And Alicia led this a wonderful discussion on what people's thoughts are on different EDI work. She put together these main takeaways. People have very different perceptions of inclusion in the Rubin project. A lot of the actual change is being done by grassroots efforts. So it's important to have these types of resources. Also, a lot of people felt like individual allies and not organizational sources of policies were the ones who actually supported them. But yeah, it was great having everyone together talking about these important issues. So.
We gave our annual update to the algorithms workshop and showed science quality metrics of the algorithms and pipelines performance on precursor data sets. This included testing the asteroid linking algorithm on archival atlas data, which yielded a press release from UW, wherein Ari discovered a new potentially hazardous asteroid. It also includes processing real lattice data coming off the observatory. We use this for getting ready for commissioning, for improving instrument signature removal, and integrating some major new components. The prompt processing framework and the alert distribution service are both live at the USDF. Thanks to Tris, Sinfang, Brianna, Eli, and Bruno for their talks. We are proud of the current performance on precursor data sets and are looking forward to commissioning with LSS TCAM. Thank you.
Hi, we had a session where we introduced IMSIM to the wider Rubin community. So for those of you who don't know, IMSIM is the image simulation program that has been developed in the desk, and a lot of you have actually used it already because it was what produced the images that were used for DC2 and then DP0 on the RSP. And so there's been a lot of recent developments, and there's a new release that's coming out. So what we wanted to do is we wanted to tell people about some of the recent developments. So if you've looked at things on the science platform, you maybe didn't see diffraction spikes before, and now you can see them into the mic. And we wanted to talk to people in the wider community about how they might get involved in the development process. So we had an interesting discussion. There were some people who were interested in doing things like adding intercluster light, possibly simulating the Oxtel or the collimated beam projector for calibration. Thanks.
This is another one where our session chair is not here, so we will read the slide.
Hello, I'm Tim, substitute for Jeff Newman. So as we all know, spectroscopic data is critical for LSST's PhotoZ calibration and for many other science projects as well. And one of the main problems there is to characterize PhotoZs actually at the depth that LSST will achieve. So synergies with existing and future spectroscopic surveys is really important. So in this session we had several overview talks from WE, Foremost, PFS, DESI, also then DESI2, and Phobos, and discussed was mostly the instrumentation, some of the timeline for when data will arrive, science cases and science teams, the subsets of different surveys, the science goals of the different surveys, and also data publication policy, because this is something that LSST should keep an eye on in order to get access to these spectra. So we need to connect to several other surveys as well, in particular also Spherix, and Euclid, of course, will also have spectra. So there's different data publication policies that need to be navigated by LSST in order to gain access. And there was a question whether NOIR can actually compile a library of all spectra that have ever been taken with NSF instruments. And there was an answer that that this is probably possible if the library only hosts the spectra and not additional data that is perhaps needed. That would make it harder. One last thing, DESI2 synergies with LSST, they're being explored through a DESC DESI interface group. There is a dedicated Slack channel to that, and if you're interested in that, please do join that. Thank you.
I'm James Buchanan. I'm the co-convener of the Blending Working Group in the Dark Energy Science Collaboration. And the basic idea of blending is that if I'm standing in front of someone else, you're not going to be able to measure them very well. We had a lot of speakers in the session. We had Lee Kelvin talking about synthetic source injection in the science pipelines. Fred Muhlekamp gave us some slides about scarlet light, the new version of scarlet in the pipelines, and also detection on chi-square coeds, which is an interesting new idea for detecting things. Shuang talked about identifying unrecognized blends based on their measured shapes and colors. And Ismael Mendoza then gave us some slides about ideas for probabilistic detection, classification, and measurement. So just a really rethinking how this whole process operates at a pretty fundamental level. And then I gave some very broad remarks about how survey depth variations just over time and over the survey footprint interact with our blending analyses. So if you're interested in these topics, please get in touch with the Blending Working Group and desk. I left some contact info below. Thanks.
Okay, so on Tuesday we had a session on early science with Ruben, what to expect in year one of operations. We provided updates on the plans for early science, not only what you can expect in year one, but how we're preparing the community to be able to work with year one data in advance of year one. So we presented updated timelines and plans. We gave a review of our data preview program, one of the key components of the early science program. You can see some images just down here. This shows you the DP2, TP0.2 area of the sky based upon the DESC simulated data set. DP0.3, we've just released, it's just come out. This is to support solar system science. DP0.3 now concludes our data preview program. The whole DP0 program was based on simulated LSST-like data, and this is the last data set that we will produce based on simulated data. As we move on to the next set of data previews, Data Preview 1, we expect that at the end of next year, and that will be based on some early LSST data taken with LSST-CAM. We also talked about data access, how you get access to the data products via the Ruben Science platform and the community brokers. These are the two key services by which the community will access data products, both leading up to the start of operations and in the operations era. And we were very fortunate to have Jamie Robinson give us a presentation on the studies he's been doing with transient science in year one. He's been working on studies of different ways that you can build incremental templates and what that means for how early we can detect objects or what we might miss based upon various different strategies. And he worked with the version 3.2, of the survey simulations produced by the survey strategy team. So it was really good to see some studies from him. We got lots of really good input from the community on the sort of things that they'd like to see in year one, and I think we have a lot to take away to think about, and next year we should be able to come back to you with some much more concrete plans for exactly what you're going to see in year one. Thank you.
Hello again. So we had a really nice session for using IMSIM for doing the commissioning that we want to do for the active optics system, which is one of the big things that we're going to be doing during commissioning in this coming year. And here's a beautiful picture on the right that was made by Josh Meyer, where you can see a blow-up of part of the focal plane. You see the vignetting as you move off towards the edge of the corner. You can see the stars in there. And then these two half rectangles are actually the wavefront sensors. So they're not exactly on the focal plane. They're a little out of focus. They're a little shifted. And so you see the out of focus donuts. So these are actually generated from the Gaia star catalog. So this is very realistic. And this is what we'll be doing when we're actually doing the commissioning. And you can learn a huge amount by looking at these objects. So if you look here on the right, on the left, you can see a blow-up of one of these donuts. You can see the spiders on it. That's what the little things are there. And you can actually see what causes the vignetting. So the reason that the things get dimmer as you go off to the edge is you can see it's actually cutting the light off. So you can learn a huge amount about what the optical system is doing, what the aberrations are, and how well the active systems with the actuators and hexapods are working to do their job. And so in the session, what we did is we learned about what's new since last year in our optics model. So a lot of what we've done in the last year has been focused on making this happen. And a lot of the inputs that we got last year were extremely important for tagging what we needed to do. And then we had a student who told us about simulating data for one of the first tests that we're going to do on the mountain for building the sensitivity matrix when we move the TMA around. And then Bryce from UW told us about the closed loop simulation, this thing called TS-IMSIM, where the idea is we take an exposure, we move the telescope, take an exposure, analyze these donuts, figure out how we should move the actuators around to correct the figure of the mirror, and then take an exposure again. And this plot in the middle shows you some early work now that's showing basically the size of the field of the PSF decreasing as a function of iterations of this process. So it's showing the system converging as we move the system into focus lock. Thank you.
Good morning, buenos dias. During the safety session on Tuesday, we talked about two important topics that we are currently working on. The first one is the fatigue mitigation program. And during the session, we talk and discuss and also show about how we get to the analysis and assessment of this the fatigue as a risk for the staff and for the project, and how we want to continue and extend the fatigue control and mitigation program during the operation. We believe that the operation includes a significant number of tasks in interaction with delicate and specific instruments and equipment, and that require high concentration and optimal physical condition during the development of the task. On other hand, we talk about the EHS merge between Rubin, Slack, and Neuer Lab, which is already on place, several activities that we already start between the two groups. And we also highlight the commitment of the management level, which is essential for the successful merge and application of the safety program for Neuer Lab during operation for Rubin. Thank you.
Hi again. I will talk on behalf of the chair of the Data Representation and Accessibility subgroup of TVS. In this session, it was quite fascinating to hear about multisensorial representation for data and ways to improve accessibility to data that are more friendly for people affected by color blindness and other type of ways that we can just improve the way we deliver data to every type of audience. The discussion was also pretty rich. We discussed about which characteristics make one representation more effective than another, and in particular, can these tools be used to do also data analysis instead of, for example, just engaging the public in a better way. For example, data sonification, among other techniques. And as action items that were identified during the session, we highlighted the need to develop standards for inclusive data representation and then train researchers so that we can make sure that they are implemented. Thank you.
I'm here representing myself, Eric Bellum, and all the people doing image subtraction, DIA work for the commissioning science unit. I'd say the brief thing is the image subtraction's working pretty decently, and we can make it better, and we can quantify and explore with better tools. So right now we're trying to make sure that more and more people within our science unit understand how to process images and do image subtraction. And then we're going to start doing some tests for that. The one specific science case that's a nice driver is the fun case of strong lensing. And then we're also pursuing some theoretical work of coming up with new different DIA algorithms or implementing ideas that have been out there and for a while. So we're going to start testing on some small data sets, come up with some metrics, I actually mean that with a capital M, to see if we're satisfying our requirements from the project for construction with a scientific interpretation and validity and robustness of that. So one particular thing was we'll start using the nice new source injection package to put in catalogs, trace those through, understand what we're losing, what we're catching, what the artifacts are, and I anticipate that we'll have some fun updates for next year. Thank you.
Hello. So on Tuesday, we had a session about citizen science with Rubin. And so as we all know, there'll be lots of fun citizen science projects coming out of Rubin. And our goal as the citizen science team here is to help you make great projects. So facilitating easy and straightforward project development, which highlights the amazing Rubin science for the public. So we are partnered with Zooniverse as an in-kind contributor, and we have built and are continuing to build a pipeline that's based on a set of Jupyter notebooks with supporting documentation that helps you send data directly from the Rubin Science platform to the Zooniverse, and we have a team ready to help you make awesome projects. We had some great discussion during the session, which was really helpful to hear from you, but this project is still under development, so we'd love to have your input. If you have any thoughts about Rubin Citizen Science, I put some links to contact there.
All right, this was our first year at the PCW accepting directly contributed abstracts for talks. And out of the 14 contributed abstracts, 7 of them fit into topical breakout sessions that were already happening. And then the remaining talks we put into this session alongside talks from our new Simone scholars. So thank you to all the speakers. We heard about pretty much all aspects of science, all across the main Rubin science pillars. So thank you to Colin, Gotham, Daryl, Bryce, Adam, Alex, and Rui for being there in that session.
So a few of us got together to talk about how we're going to celebrate this great telescope and observatory that we're building. So we talked about 2 main things, System First Light, which is largely a media event, and the dedication ceremony, which is the on-site equivalent. So System First Light is kind of ramping up already now with momentum building, which is being led by EPO. If you want to talk to them about your science, fill in this link here. The first release went out yesterday. I'm hoping many of you saw that. And the images group is thinking about what the first light image might be and also has a goal for sonification. So the on-site events, obviously there will be one in Chile, but we're hoping that it's a worldwide on-site events across many, many sites. In Chile, it's slated for October 25, still TBD, of course, over a period of 3 days. So we're very interested to hear ideas from you, your feedback, and anything that you might want to tell us. through these various links, you can give us that information. So look out for more updates coming soon. And if you want to see the full slide deck, go to the session page and you can see everything that we discussed there. And we hope that the world hears about Rubin. We really want to create this storm and have everyone know the Rubin name.
Okay, the Wednesday speakers should start to gather, please.
Hi everyone, so this is a slide that I'm presenting on behalf of Apragita Verma. So we had a session about all the software that are used in the Rubin community, in the project or the science collaboration. We had talks from DM, from TVS Science Collaboration and Desk, from Link and the In-Kind program. So we covered, we kind of made an overview, best practices, coding standards that people have. And some of the takeaway is that we want to encourage people to talk together, software developers to talk together. And Frosty highlighted this idea of interoperability between different software communities. We also want to develop software best practices and training. And we need a space for some ways to communicate. So that's the idea of the Rubin Software Forum, which the attendees were really supportive of. So if you're interested in this idea, and if you have any inputs you would like to add, please DM Apragita on Slack. Thank you.
Hi, me again, and I'm not Alicia. She did run a session called What's Your Beef with the Hiring Process, and I couldn't resist the title, so I attended that. And she introduced the topic very well with the kind of the hot spots, that sometimes obstacles or difficulties for people applying and sometimes for the people also interviewing. And then we divided up into groups and came up with some ideas and discussed those. So it was a really very productive session organized pretty nicely by Alicia. Some of the things we touched on, in particular, salaries, transparency in both directions, both when you set a range, the candidates should know about that somehow coming in, and also they should be able to disclose ahead of time how much they're really expecting. Otherwise, sometimes things fall apart at the end. And recruitment time. This was something we spent a lot of time talking about because it is a lengthy process, usually months long from the time somebody actually applies or the ad is posted and the candidate is actually hired. It takes a long time. It's a difficult thing to get through, and it's multiple interviews. And so we talked a little bit about trying to speed that up and keep candidates advised as you go along the way. So that they don't lose interest in the job and you lose good candidates that way. We also talked about diversity and trying to not only have a good capable team working on Rubin, but also a good diverse team working on Rubin that has natural advantages in all kinds of ways. And sometimes the job descriptions or the way the job is advertised contributes to that in ways that we could improve, specific ways that we could improve advertisements and job descriptions to recruit a wider group of people. We also talked a little bit about the candidate's experience and how they see the process. It was really an interesting group because there were people from all levels of management, people who were just working there and wanted to have good people working with them, and also a group of people who were clearly interested in applying for work with Rubin and being able to work long-term in operation. So it was really an interesting forum. And I know, Alicia, actually, if you click on the link for it, there's a live link for you to be able to input anything you'd like to include into this discussion. And as I say, it was really productive, and I salute Alicia for putting it together. Thank you.
Hi all, I'm Guillermo Cabrera, but I'm here on behalf of Francisco Forster, who had to catch a plane. So the question we were trying to address during this workshop, are we ready for real-time transient identification, turns to be like, if we get a specific alert, are we ready to trigger an 8-meter telescope in order to do follow-up? We had really interesting talks by Forster, Wilson, Reyes, Jainaga, Andrioni, Knopp, Miles, Gagliano. And my take on this is that we're not ready. But, optimistically speaking, we think that we will be ready by 2025. Hope everyone on the session agrees with me. Thanks.
Okay, I'm Keith Bechtel. So we had a session on the system test plan for on-sky commissioning with LSSTCAM. So the whole concept of the session is that we want to make the most efficient use of the finite commissioning time as possible. And so we plan to interleave the engineering and science activities. And what this means is that it would give us an opportunity for more iteration, maximizing time for thinking, and being able to think carefully about how to prioritize the tests. So we discussed a draft of this on-sky test plan that would incorporate the data acquisition, the data processing, the verification with the calibration hardware, AOS commissioning, and science programs all together. This led to vigorous discussion, which was fantastic, both in the whole group and in small groups. And this generated a document with a number of tests and refinements to the draft plan. So we got some really good feedback. Thanks, everyone, for participating.
No. So in the session for supporting science at small and underserved institutions, we started with 4 talks. We heard about the expansion partnership program from the LSST Discovery Alliance. We also heard about some more funding opportunities from the DOE and NSF. And then Louise Edwards gave an amazing presentation on the program that she's been leading for the last few years, using the data preview to build partnerships and expertise across primarily undergraduate institutions. And then we had a very active discussion. I couldn't put all of the takeaways here, but they were mainly in 2 themes. One of the big things was like, how can scientists at large research institutions and small and underserved institutions collaborate with each other? There was discussion of expectations and distribution of work in these partnerships. We talked about some positive examples on fostering collaboration. How can people just meet potential collaborators and just jump in right away into actually doing science? And then also, how can scientists at small and underserved institutions find each other, basically? Can we have some sort of organization where people can easily find each other and share experiences and resources? But, yep.
I'm giving an update on the in-kind community session for Apergita and the rest of the in-kind team. So we presented an overview and sort of status on the in-kind program and updating on different types of contribution types and how things are progressing there, and an update on how data rights and agreements are going. Just some of the highlights of this: we have about 60 active in-kind contributions ongoing right now. 45 of them went through a really overall positive fiscal year 22 annual evaluation. We're about to begin the annual evaluation for 23 very, very soon. International data rights agreements are going from this coming soon to actually starting to happen and getting into hands of people, and so that's going soon. And we're going to be opening up for invitations for recipient groups to start telling us their pressing needs, the things that are missing yet, and so that we can then perhaps expand this to US, Chilean, and existing in-kind programs to be able to meet those needs. We talked about how we're going to be progressing from sort of abstract to real opportunities for telescope time in the coming year. We understand that the lack of data rights agreement so far has been somewhat of a challenge in being able to make these contributions happen. And we're starting to get a wider, more access on the recipient side for some of these contributions. And of course, if you have ever any questions or anything about the in-kind program need it, please contact us. That's what we're here for.
So in this session, we had a variety of presentations on the current status and future plans for developing the alert follow-up ecosystem. We saw that the General Coordinates Network is planning to change their format to have alerts coming out via on JSON over Kafka messaging system. We got an update from the Rubin alert team, and especially how they're going to be releasing early alerts for testing to the 7 full-stream brokers that have been chosen, and we had updates from 3 of those projects, Antares, Alerce, and Pit Google, and their current status and their plans. They're all currently processing and classifying alerts from ZTF and are scaling up to LSSC event rates. We had an update on various tools for science teams for doing follow-up, including tools for filtering the outputs from the brokers, making observation requests, and sharing data and observation plans. And there was an update on the AEON follow-up network, which includes Las Cumbres Observatory, SOAR, Gemini, and soon the Blanco telescope. This provides programmatic interfaces for accepting observation requests, doing dynamic Q observing, and getting the data back to people. And this may be expanded with the in-kind telescope contributions. There's also there was a lot of interest in expanding on this, and that will be done at upcoming meetings in September and in October here in Tucson. Thanks.
Hello, my name is Federica Bianco. I ran this session together with Lynn Jones, who is on a plane by now. This session was updating the community on the work of the Survey Strategy Optimization Committee on optimizing the survey strategy of LSST to maximize the science return. I want to acknowledge all the people that contribute to this work, which is the Rubin LSST community at large, the Survey Strategy Team, and the Survey Cadence Optimization Committee. In the session, we presented a new baseline for the survey strategy, which is baseline 3.2. We updated the community on the open question that the Survey Cadence Optimization Committee had identified in its last recommendation, which is PSTN 055, which was released in December 2023. Some tasks have already been solved. Some have active task forces working on them that include members of the SCOC and of the community. We are organizing a workshop at Berkeley, likely early 2024, to finalize the recommendation on targets of opportunity, and Igor Andrioni is working very hard to make sure that it's a productive workshop where we get to a final recommendations for that, and we also discuss the tasks that require additional information, such as information from commissioning and work with the early science team, particularly for the survey strategy in year 1. And finally, we talked about what the SCOC will do during operations. The SCOC is a standing committee of Rubin Observatory and will continue to evaluate the success of the scientific success of LSST and how to maximize it through survey strategy changes. We plan on reviewing the survey strategy annually, and we also have a number of ways in which the community can stay in touch with us throughout the year to tell us how we could improve the survey strategy.
I think this is one where we read the slide. Yep.
Hi, good morning, everyone. So we had a session, I'm Guillaume McGee, as a grad student from Stanford. We had a session on the active optics commissioning group. From last year, there's been a lot of progress on thinking and discussing what are we exactly going to do and have a detailed plan on our first night on Sky. So we had an overview of that commissioning plan and the status by Sandrine and Andy Connolly and Sandrine Thomas. Then we also had an insightful discussion on a set of different AOS commissioning tests. We had a short update on TS IMSIM by Bryce Kalmbach from UW. And well, in general, we chose 5 different tests, and we discussed on the different analysis tools that we will need specifically for those, as well as how can we leverage the tools that TSMC is providing to us now to generate realistic data that can allow us to rehearse with these analysis tools. And most importantly, we had a lot of fun.
Hey, we had another very successful unconference this year on Wednesday. I just want to thank everyone who suggested topic ideas, everyone who voted, and then everyone who went and participated in the unconference. It looked like a variety of good topics this year, and we're going to hear about some of them. So, yeah.
Okay, we had a session about designing a pinhole for Oxtel, and the idea is to stick a pinhole out in front of the detector and gaze out, and that way image bits of the telescope near to the usual optical path, and use this to hopefully track down stray light issues, including this thing called the waffle, which is a feature that we see coming off Oxtel. You can see an example here. So we were treated to an impromptu lecture from Professor Stubbs on pinholes, and then got into the design. A small rectangular aluminum plate looks like it'll fit the bill and would fit a slot on the disperser wheel. The disperser stage is movable, so that lets us play with the field of view a little bit. We would just black anodize this, drill it, and thread it for multiple positions to accommodate manufactured pinholes that could just then be screwed in. And the different positions would allow us to try different pointings, and we might be able to recycle some spare pinholes from the LSST cam pinhole plate. Stubbs Lab volunteered to manufacture this. It could show up in La Serena as soon as September. Late breaking, Chuck might do it instead, and there's some squabbling now about whether we need multiple pinholes, but we'll figure it out. And then I'll be seeking some guidance on what we might have to do to OBS packages to accommodate this, and work with the Oxtel observing team to try and get these experiments on the books.
Okay, so I'm presenting this on behalf of this team of conspirators here, myself, Phil Marshall, and Sandrine Thomas, although of course Phil actually did most of the work for this, including running the session and writing the slide. So Phil has a nice phrase near the bottom of this slide about upgrading the Rubin Code of Conduct and the Science Collaboration Code of Conduct, which is a way to sort of express what are the values of the community and what kind of community do we want to see. And so 22 of us got together to try to understand this question. The activities in the room were really focused on these 3 bullets that you see here, all about upgrading the code of conduct to sort of help the community work. We spent some time in small groups discussing the proposed values statement, which is drafted at the link you see here, and a web form is available for everybody to fill out to provide your input on these issues, so please do think about that and fill this in. And then we had what I would describe as a frank and productive discussion about some of the situations that codes of conduct might be used to address and to provide a framework in which situations can be handled. Followed by discussion about trying to write down, in some sense, what a practical solution to some of these problems might actually be. So that process has started. Again, to remind everybody, if you're interested, please do fill in the form, which will form part of this information gathering phase. What's coming next is that Ruben will form a working group to absorb and expand this input, starting with the above set of use cases, but to be expanded based on input. And that will then be used to drive upgrades to the Ruben Code of Conduct after that. The science collaborations are also in the process of upgrading our codes of conduct as well, and so there'll be coordination between the science collaborations and the project. So please watch this space, and for a third time, I encourage you to check out the Google form up there. Thank you all.
So we had a interesting unconference on this issue of trying to detect glints in the alert stream. The problem being that the actual postage stamp that's released under the current plan is only 6 by 6 arc seconds, and for a lot of science cases, you need a bigger picture. The particular example here that was given is for a supernova discovery, where what's happening is that you get a false discovery because a satellite is zipping across the field of view and tumbling and giving you a series of glints, a string of beads, basically thing. But also there are other use cases. For example, it was mentioned earlier, strong lensing, where you need to get the big picture of the, to get all the galaxies in the foreground to solve the mass sheet degeneracy. But there are a number of other interesting cases. And so what was suggested is a multi-scale postage stamp where you end up not necessarily using any more pixels in the released alert, but using a multi-scale approach, which is shown in the lower right. Anyway, this whole idea of either that approach or a somewhat larger field of view being released as a part of the alert is now being studied by Ruben Data Management. Thank you.
Hi, I'm Gautam Narayan, and I'll introduce the last of the unconferences, which is a discussion about a set of joint Ruben and Ruben simulations. This is an effort led by NASA and Alina Kiesling, and she'll be working with DESC and the Roman Supernova Pit to produce these simulations. The timescale is very soon. We'll be doing this by the end of 2023 because the Theta cluster at Argonne National Lab is retiring, and we'll be using all of the nodes and all of the compute hours for about a month to make them. So we defined what was in scope. The simulations will have a whole bunch of transient models that cover the optical to the near infrared, one deep drilling field in Ruben parlance, or the high latitude time domain survey if you're a Roman person, and about 100 square degrees of the wide fast deep area, which is the wide area survey in Roman. Some of those will hopefully also include regions where there are clusters to test things like strong lensing. What's out of scope currently because of the timeline is galactic plane, true up-the-ramp Roman sims, and moving objects. So things like satellites included there. But all of those things are doable on the longer term, and so they may be actually possible in future, subject to data availability. This is, I think, a really exciting opportunity for Roman and Ruben to work together. So please do come chat with us more if you'd like to hear more and get involved. Thank you.
Thursday speakers. Okay. The speakers, remember how the students did it and they were like coming close to the stage and they did such a good job and then they just exited off this side instead? If we could try and mimic what the students were doing, that would be great. Just, yeah. Yay. Thank you. Good, good. I know you don't always know exactly if your slide's going to come up, but just come this way. Great, good. Yeah, and then try to remember to go off the stage the other way. Yeah. All right, we're over halfway done with it. Good job. Oh. Yep, there we go.
Hey, I'm Peter Ferguson, and this session was a discussion on the dark matter science that we hope to do with LSST. There's a lot of different probes that go over lots of different science collaborations that we're hoping to use to learn about dark matter. And so we broke into some small discussion groups and then came back together. And in particular, we discussed some microlensing and strong gravitational lensing, nearby dwarf galaxies, and anomalous energy loss in stars. There's a lot of infrastructure, precursor, and simulations work we still need to do to prepare for data, but it's exciting that data is coming soon. And if anyone wants to get involved with dark matter, I'm part of the Desk Dark Matter Working Group, co-convener with Nora Ship. So get in touch. Thanks.
So I'm Leanne Guy, and I'm the AD of the System Performance Department and Operations. We had our very first all-hands meeting at this PCW this year. System Performance is a new department in operations. It has no construction counterpart, unlike DM, so we're not flowing in continuing work. We're pulling in people from all across the project to make a new department whose job it is to track the LSST survey as a whole and to make sure that it's proceeding with the efficiency and fidelity needed to achieve the science requirements of the 10-year survey. And so here you see a nice photo of all of us who were here in person, we basically reviewed what the department's about, what we're going to do, and our objectives. We then had a walkthrough of the teams, everyone presented themselves, and we looked at some of the work that's been done in pre-operations in FY23 by the department. Here you can see some images of the waffle that's already been mentioned. This is one of the artifacts we're seeing in Augstel data, and the verification and validation team are doing a lot of work already on this, on trying to understand this and many other artifacts that we're seeing in the commissioning data. I've already mentioned DP0.2, a few people have. This was one of the deliveries that the community science team supported, delivered by data management, supported by the community science team in System Performance, who've produced a huge range of tutorials and demos and organized virtual workshops to get the community going with using these data previews. This shows you a map of the days, a simulation of the days of the survey and the total number of visits covered. This is the work of the survey scheduling team to track the progress of the survey. Are we on track to meet the science goals? And this here shows you some of the work from the systems engineering team in supporting documentation management. In particular, they're working with the CMMS development at the moment to support building that up and providing documentation processes. Thank you to everyone who came along, not just from the department, but from outside as well, to give us input, ask us questions. It was great to hear focus from outside of the department as well about what you'd like to hear from us and how we can work better. Thank you.
The sky is falling. So we expect, realistically, about 100,000 low Earth orbiting satellites by mid-LSST survey. I think there's no stopping that. It's going to happen. Everybody agrees it's going to happen. Some are currently as bright as first magnitude. More of those are going to be launched. Many right now are fourth to sixth magnitude, and that's going to give us problems in terms of the crosstalk induced on the focal plane. We heard a number of really nice presentations, one of which was from the National Science Foundation, where they have achieved agreements with various satellite operators to try to minimize the emission in the optical through a number of different techniques. We had a report on a new software for predicting the LEOSat brightness as a function of time and space, in particular as it crosses the focal plane. And on the right, you can see observations during a sunset in which you have various different parts of the sky illuminated by reflections from various components of the satellite. We have we heard a report on the first high-resolution measurements of the LSST CCD crosstalk. It actually is nonlinear, but the good news is that it's a smooth nonlinear function, which could be fit by 3 parameters. So we may be able to correct the crosstalk in the data. If the LEOsats are fainter than 6.5 magnitude, depending on their height, however, see above observations. So we have a problem. We heard about new analysis of the streak profiles for LEOsats of the various different existing and planned sizes from 3 meters in size to 50 meters. The streak detection software parameters, actually, there are lots of them, and they depend on the size, geometry, height, and orientation of the satellite. This leads, actually, in the general case, to a double peak or multiple peak structure in the streak profile as you go across the streak. So they can, you have 2 or 3 streaks, which creates difficulties in trying to detect them. So further development is needed for streak detection. We heard the first report of a full end-to-end science impact study due to the effects of satellites, this time in the cosmology area. Next, folks are going to try to detect try to study the time domain. So we now know, depending on your science, that these satellites will cause systematic errors, depending on your science. Some cases, 0. Other cases, a lot to worry about. However, overall, I think that there's a negligible effect from lost pixel. So the lost real estate on the focal plane, unless you have a first magnitude satellite, is pretty much a non-issue unless you happen to be trying to detect that electromagnetic counterpart for a mirrored gravitational wave event. Thank you.
Great. Yeah, we had a great session on discussing in-kind computing resources. It was split into 2 parts. One was presentations, where we summarized the virtual workshop that we held on in-kind computing resources earlier this year. All of that material is available if you want to take a look at it. The workshop focused on exploring the demand from the user side, so where we have now 48 contributed science use cases to explore in detail, and also exploring the challenges from the technical side, so how do we meet that demand. We also had a nice presentation from the Polish IDAC showing considerable progress in getting ready for the data that will come and the users that will come with it, from Agnieszka Polo. Second, we had a lot of discussion, right? So this discussion actually started in our unconference session in the lobby. But the questions that we discussed were things like how we facilitate connecting the users to the IDACs, what data is needed at which IDAC, and here we determined it's time for a definition of the object-like catalog, the popular data product for IDACs. We also discussed preparing for data distribution, and here we have an action item to start establishing those Rusio endpoints that are needed and planning the distribution network. We talked about software infrastructure and services, and including a good discussion on Rubin Science Platform associated tooling and which ones are appropriate for what use cases. We talked about policy considerations and also plans for user support. And if you're an in-kind IDAC contributor, see if you can spot the poorly hidden subliminal message in this slide. Thank you.
We had a whole session on Data Preview 0, which is currently serving simulated data sets in the same format as future LSST data. If you are interested in having a Rubin Science Platform account and accessing any of the data sets available through Data Preview 0, please go ahead. Accounts are available. Follow the Getting Started with DP0 checklist that you will see right in an important banner if you go to the URL dp0-2.lsst.io. We're currently serving 2 main simulated releases, DP0.2 and 0.3, where 0.2 is extragalactic images and catalogs, and it also has some stars and some Type 1a supernovae, whereas the 0.3 is solar system only, catalogs only. In this session, we also had flash talks from some people who've been working with DP0. That was Bob and Matt and Jeff, all gave flash talks, so thank you guys. And then we had a more detailed look at what's in DP0.3, the solar system catalogs, along with some hands-on tutorials about how to start accessing those tables, how to make queries, and how to make some plots of those solar system data. And all that was done by Mario Jurek. Yeah, that's a very nice picture. Yeah. Okay.
Okay, so Steve Ritz and I organized a session on information sharing during commissioning. So the topic here was to introduce some of the boundary conditions regarding how information goes out from the project to the community, and also to outline a set of policies and guidelines that would promote the following goals. So we want to get timely information to the Rubin Science community. The project team needs to be able to focus on the time-sensitive work of commissioning, and we also want to make sure that we maximize public engagement by releasing, for example, images strategically, for example, at the System First Light celebration. So we had a walkthrough of a draft policy and guidelines, and had a lot of excellent discussion, raised a lot of really interesting scenarios for us to think through. So Steve and I and others are going to work through that feedback and revise the draft of the document based on that. Thanks everyone for participating.
Hi, I'm Aaron Meisner. I'm going to be briefly summarizing a session that we had yesterday afternoon, talking about the topic of Rubin tools applied to DCAM and also other precursor data sets. We had a very nicely attended session, 4 great talks where representatives of both the community and the project team were involved, and also a nice group discussion at the end. And so I'm just going to highlight a few of the takeaways from my point of view very briefly. One is just to reiterate that there is very strong community interest in reducing DCAM data with the LSST stack. Many in the room are eager to understand how well the NORLab community pipeline and the LSST science pipelines compare in detail in terms of their DCAM data reductions. We received some important advice from DM about deploying the LSST pipelines at scale in terms of the BPS batching system. And we also, one productive outcome of this was we identified some areas where the community may be able to contribute back to the LSST stack in specific ways. So some examples of this were refining the CFHT megacam support and DCAM brighter, fatter corrections and coefficients. At the bottom, I'm just showing one of the things that I thought was a highlight from the talks. This is a plot made by Shenming Fu, who's a member of the community working at NORLab CSDC and has been deploying the LSST pipelines on a lot of archival DCAM data. And so I thought this was a really nice picture of some of the difference imaging and some of the light curves that Shenming has been creating with the LSST pipelines on DCAM data, in this case for an M-dwarf flare. So thank you.
Hi, I'm Alexandra Goff. I'm a web developer with EPO. We had a session sharing the EPO component libraries that we've been developing over the last year and letting other developers on other teams who have websites that fall under the Rubin project know how to use them, how to make use of them, and take advantage of what we've been building. We had a chance to tour through our online interface for browsing the components, along with the astronomy widgets that we've been developing, discussed what some of the improvements we can make that would make it easier for others in the project to take advantage of our work. There's a link up here to the interface to browse our library. And yeah, just had a really great opportunity to share our work and see if others can use it as well.
Hello, I'm Federica Bianco. I'm speaking on behalf of the organizer of Discovering the Unknown. This session was organized by Xiaolong Li, Ashish Mahabal, and myself. During this session, we had both contributed talks and discussion about how do we maximize the survey strategy of Rubin and how do we develop data analytic tools to discover unknown unknowns or anomalies in our data. We focused on all kinds of unknowns, time domain unknowns, proper motion unknowns, unknowns in the extragalactic sky, and solar system unknowns. We also announced the formation of a new working group of the Informatic and Statistics Science collaborations, pending approval, but approval expected to come swiftly, that will focus on anomaly detection. And since the ISSC is a methodological group, this group will focus on anomaly detection in all fields, and people can bring expertise as well as problems to this group to figure out how we will detect the unexpected with LSST. I want to mention the speakers. The session started off with, with me not very promptly soliciting talks, but then it got really stacked up with a lot of speakers. So we had talks by Ashish Mahabal, Xiaolong Li, Will Clarkson, Harry Hines, and Jessica Polo, Konstantin Malachev, Ashley Villar, Chris Linton, Abhi Shah, and Patrick Alejo. And you can see the talks. It was streamed on Zoom, so you can see the session that was recorded. We also put some thought into what we think are going to be the things, the anomalous things that LSST will have a hard time discovering. And a few examples, both in words and graphical depictions, are in these slides. Short events, long events, spatially resolved, time-evolving events, saturated events, things behind the streaks, things that are embedded in the templates. And I think there's more, so please join our Slack channel and tell us what other things we should think about discovering with LSST.
Hello, Andrew Sterner with the LSST Discovery Alliance. Excuse me. As you've heard in the plenary on Monday, the LSST Corporation is now the LSST Discovery Alliance. So in this session, we brought together a number of members from the LSST DA community, from our various programs. Beth talked about the many different programs and overview, and focused on the expansion partnership program, what we're trying to grow and diversify our membership, to really think carefully about what's the right way of bringing in members from smaller and under-resourced institutions in a way that they can actually effectively become partners in the Alliance. Alex Malls from the Link Frameworks project team talked about the various parts of the Link program to accelerate this infrastructure of the science that's going to be going on in the incubators program. Tansu Delan, who's one of our first cohort of Catalyst Fellows, gave a short talk about that program, and it's now at the end of its first year. And Jake Kurlander and Guillaume Megas Omar, who are PhD students in the Data Science Fellowship Program, talked about the benefits of that program as far as ramping them up in data science with professional development that's focused on at an early career stage. So thank you very much.
Hey, it's Peter Ferguson again, presenting on behalf of Kevin Reel. So this is a picture we're showing here of the telescope mount with the M1 and M3 mirror cell on it. which is the big thing going right now, but there's lots of progress that's made in the last year. We've put ComCam, the M1M3 mirror cell, both on the telescope mount, as well as started doing the dynamic testing with all of that. And an amazing amount of, Kevin talked about an amazing amount of things that are going to happen in the next year. The LSST cam is going to be in Chile and then later put on the telescope mount. The M2 cell and glass will end up on the mount, and the M1, M3 cell and glass will end up on the mount. And within the next year, we expect to have the first photon, which is super exciting. And then Dominique and I talked a little bit about some of the data analysis we've been doing to help assist with commissioning. And Kevin said many times that you, yes you, should help with the data analysis and get in touch with him if you want to do that.
Yeah, so I'm presenting this session summary on behalf of the organizer, Julie McHenry. So the session was about Roman-Rubin synergies, specifically in the context of the ongoing process that Roman has to define their core community surveys. So the session focused on how joint Roman-Rubin science needs will influence design of the Roman core community surveys. And then we heard examples of joint science and how this might influence survey design for each of the 3 core Roman surveys. So the session started out with an overview of Roman's capabilities and complementarity with Rubin from Julie McHenry. Then Caroline Gilbert gave an overview of the ongoing process to define these Roman core community surveys. And then we just heard different science examples from the Roman-Rubin community pertaining to each of the different surveys. So with the Galactic Bulge Time Domain Survey, we heard from Annabelle Varela about microlensing with Roman and Rubin. Then we heard from Igor Andrioni about basically transients like kilonova in the high latitude time domain survey in combination with Roman and Rubin. And lastly, there were a couple of science pitches related to the high latitude wide area survey with Roman in combination with Rubin. One of them being cosmology ideas from Tim Eifler, and then the last one was me talking about ultra-cool dwarf science with the combination of Roman and Rubin.
Hello, I'm Claire Higgs on behalf of the EPO team. So we had an open house yesterday, which is a great opportunity for people to come by and talk about various EPO initiatives, from our education investigations, gallery of visuals, citizen science. We had people recording cosmic clips. So these were just a kind of 2 to 5 minute conversation about what you're excited for with Rubin. If you missed your chance to have a cosmic clip, please reach out. We can keep recording them. In the busyness that is PCW, you may have missed that we put out 2 exciting new things this week. We have a science release about interstellar objects. This is the first in a series of articles telling the public about some of the cool things that Rubin is going to do. So there's a link for both the Spanish and English versions there. We also released a new animated video that's on YouTube, and I've also put the links there, and you should check them both out because they're really cool.
All right, can we get our Friday speakers? Should only be like 3 or 4 of you. All right, this morning we started off with the Users Committee meeting. The Rubin Users Committee is charged with soliciting feedback from the science community, the users of the LSST data products and Rubin Science Platform, and then recommending improvements in their twice-yearly reports that are delivered to the Rubin Operations Director. We have many members of the Users Committee here at this meeting. You can find more information about them on their website. You are all welcome to email them with your concerns at any time at that email address, or to look through the reports that they've been producing, which are available in the Rubin Community Forum under the Science category with the tag Users Committee. So this morning in particular, we heard about some developments that should be expected in the Rubin Science platform over the next couple of years. And we also discussed the role of the Users Committee through commissioning, and in particular, strategies to help the Users Committee talk more directly with users. So if you have been participating in Data Preview 0 over the last couple of years, do keep an eye out for messages inviting you to directly interact with members of our Users Committee, and please do provide your candid feedback when requested. We appreciate it.
So this lively session this morning was chaired by Agnes Fateh, sitting over there, as well as me, Yuanyuan Zhang. So if you missed this session but wants to catch up, we do have meeting notes available. And we also have a secret video recording available upon request, but you have to request within the next 2 weeks. So the goal of this session is to identify needs and solutions for machine learning applications with Rubin and to brainstorm some standard practices. The session started with 4 wonderful talks by Guillermo, Nima, Alex, and Simona to help us set in the context for machine learning applications in Rubin. And then the discussions got kicked off by a powerful question from the audience, Adam Bolton, which is, what are the biggest barriers to your applications? So the immediate answer to that question was data, 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 everything about data. And one of the audience and speaker, Guillermo, mentioned that 70 to 80% of the time they spend on machine learning is dealing with data, finding data, cleaning up data, and trying to get data from some other people. We also talked about the need to share training sets. We recognized that this is necessary for reproducibility of scientific results, and also same objects can have different training labels for different applications. So we don't really want to store the same objects information 10,000s of times in Rubin. And finally, we pivoted away a little bit from data and talked about the need for GPUs and how that could explode with the coming of Rubin data. We recognized that the need for GPU resources could leave some of the groups behind if they are short on computing resources. And finally, judging from the unresolved hands in the audience at the end of the session, we think there is a need to continue those discussions, and hopefully those discussions will continue in the Slack workspace or in other Rubin forums. Thank you.
Hi. Jim Bosch and I ran the Reducing Weak Cleansing Shear Catalog session this morning. This was largely a status update based kind of a session followed by a lot of active discussion here. So Jim Bosch gave an overview and introduction to shear measurement plans from LST Science side, which included what the plans were initially, how it has evolved, and how this has also worked so far with the Hyper Supreme Cam data, with and also laying a path for how it is going to look like in the future. And then I presented the idea and the status behind what we call as cell-based coords, which are like small cell edge-free coords that have well-defined point spread functions attached to the images. So this is going to be the images on which any shear measurement algorithm or recleansing measurement algorithm is going to be run. And Matt Becker presented an overview or introduction to the meta-calibration and meta-detection algorithm, which just recently data management has formalized to run it as part of their DRP campaign, which means it will be produced by the data management and will be part of the data releases. That was followed by a few more operational aspects and a discussion about data products, which also included plenty of active discussion about how these data products are going to look like, how the shear data product or the shear catalog is going to interact with the other catalogs that will come out of the data management pipeline, and how we should be looking at photometric redshifts and so on. This was in the Pima room, which means it's recorded. So if you'd like to catch up on all the discussions, it should be available soon. Thanks.
So I had the wonderful opportunity this morning to host a discussion on neurodiversity in the Rubin LSST community. We talked about the different elements of neurodiversity and how they are expressed within our workplaces and our large community, and really led a really great discussion on different ways that we can be more accepting and accessibility to have a larger inclusive space for our wide community. And we have lots of great ideas to start feeding back into the various organizations.
Okay, so we had a session this morning to bring together experts from all over the field, but to discuss how best to help Rubin become the spectacular discovery machine it should be for crowded stellar fields. And this motivating question, what has to happen between now and survey start to really make this work? It's a field that's crowded with questions and interesting issues, and there are great presentations covering a range of them. The punchline from the session is there is a lot of work to do, but I think it's probably solvable. And so we want to continue the conversation, likely on Slack and community, and we'd like to stand up a workshop optimistically later this year, maybe more realistically early 2024, to continue to work on this and help sort of converge towards helping Rubin reach its potential in crowded fields. Thanks very much.
Okay, we're going to move on to Bob for closing comments, but let's thank all of our speakers again, please.
How to wrap up? It's difficult, and it was a great week, and so much happened, and so much is happening that I'll never do it justice. But let's just say a few words, and then get on with it. First of all, I want to say this was the first PCW, the 13th in the series that the operations team had the honor and the privilege to lead, and we really enjoyed doing that. It was a lot of work, not by me, but by others on the ops team, and they did a fantastic job, and so we're really excited about moving ahead with the program. We're getting closer to operations. We're doing some operations activities, and as we go forward together, we're going to be talking a lot more about science and the things we're going to do over the next 10 years, so it's super exciting. I want to thank our operations partners in the Wire Lab and Slack for continuing to support us now and through into operations. And I want to acknowledge again the tremendous support we get from our funding agencies, NSF and DOE, which we couldn't do any of this without. And then I want to thank you all. I mean, this has been a fantastic meeting. It is such a pleasure for me and an honor to be part of this community. It is a really great community. I think we saw that reflected in everything that's happened this week, but it was on display this morning in this wrap-up session. We are a welcoming community. We are an inclusive community, and people are finding the space to be who they are within this community and contribute in many, many different ways. And I think that's just, it's just fantastic. We're going to do a lot of great science together. I want to acknowledge the tremendous work that the construction team is doing as we have this opportunity to get together and talk about science. They are making real progress, and we're getting much closer to that point where we see the data flow. So the team led by Victor and Jelko and Sandrine and Aaron are doing a great job on all our behalfs, and I wanted to acknowledge that. So look, it's full speed ahead. We're getting really close. There's a lot happening. You've heard about it all this week. We really look forward to seeing that camera get up on the summit and continue toward first light and first photon next year. By 2025, you all will be studying, real alerts. There will be the science validation observations that we took that will be packaged up and delivered to you through the science platform, so you can start doing science. That will include Data Preview 1
and we'll start the survey. And then shortly after that, we'll continue to deliver those data products, and we'll keep running on the survey. So this is a chance to really take stock of where you're at with your own personal goals. As you think about real plans and funding proposals, those are the things that you can be looking at to develop that plan and get on with it. So the future is now. If you have questions or concerns about any of this, let us know. Talk to us. I had it was great to see all your people, your faces be here together this week. I didn't get to talk to everyone. But if you have questions or concerns, we're always available to talk to. So please just shoot us an email or a Slack message or call us up. We are already looking forward to the next meeting. We are going to plan right now for a virtual meeting next year. And there's really 3 important reasons why to us that makes sense, and I hope you will agree with us. One of them is we will be right in the midst of the final push to get everything done, and allowing the space for the construction project to do that while they can still connect as they are able to a virtual meeting is important. I believe that there is a strong connection to our community that can happen through a virtual meeting and bring many more people in at a given time than are able to travel to an in-person meeting. And so I think that's an important option to have. And then I think we need to honor our commitment to save the planet. We need to travel less. And that's just where we're at these days. I know we all get so much out of these meetings, but there are sacrifices we have to make. And one of the things we can do is alternate our cadence of meetings to have some of each kind. But I think we really need to take that seriously. So we plan to alternate on some cadence the flavor of the meeting from virtual and in person as we go forward. We have this exit survey that should take you 10 minutes or less, so we really encourage you to do that. Please get your input into us before the 18th of August, and we will take all your considered feedback into account as we plan how we go forward. I really thought this meeting worked out well. It's a little different format than we've done in the past, but we're happy to take your comments on that. This is the last slide, I think. I'm so impressed with the work that this team did. This is a slide that shows the many contributors who logistically, scientifically, administratively pulled off this meeting. Thanks to Melissa and Rand Powell in particular for leading this whole effort this year. I think it was a great meeting. But we had folks from IT, we had Scientific Organizing Committee, we had administrative help, we had overall design of the meeting, we had support from the construction team and the operations team. So I really just want to acknowledge the tremendous effort of this group and how they made for a very, very successful meeting. So join me in giving them a round of applause. Okay, that's it. Thanks and have safe travels.